Today's topic is about cable sizing calculation. How we can calculate the size of the appropriate cable. That's why that can flow the right amount of current without any hazards. So we have to remember the three most important points in our mind. The first is the short circuit criteria, second is ampacity criteria, and third is voltage drop criteria. So these three criteria is parallel important to selection of right cable size for the right requirements. So first we discussed about the short circuit criteria. It is also called the minimum cross section required. What is A? A is the cross sectional area. A equal to I root over T by K square mm. So by help of this formula we can easily calculate the right amount of square meter of cable that is being used for any particular necessary purpose. So what is I? I is the fault current, T is the time to withstand the fault current, K is the constant cable materials. So if any manufacturers of cable can identify or provide data that this amount of fault current can flow, so you can easily calculate the cross sectional area. That's why it will be very easy for you to identify. So suppose we considering a cable can carry 50 kilo ampere of fault current and the voltage is 415 volt. So what is the cross sectional area? Then 50,000 into root 0.2. 0.2 is the time to withstand the fault current. So we are putting the value of 0.2 here. And what is 143.08? For cable has the two type of material, XLP and PVC. So XLP cable also have two parts, copper and aluminium. Copper and aluminium has the different factors. Here K is the constant cable material. Depending on the material, K is just different. So for the copper it is 143.08 and for aluminium 94.48. For PVC it is, for PVC copper cable the K factor is 115 and the aluminium cable is 76.03. XLP cable can sustain the temperature of 90 degrees Celsius and the PVC cable can withstand or sustain the temperature of 70 degrees Celsius. By putting the value of the copper XLP here, we are getting the square meter of 156.28 square meter. Because this is not the standard square meter, so nearest square meter you should have to select it. So 185 square mm. So this is the first step or first procedures to identify the square meter of cable depending on the fault current and the time of withstand. By help of this and the K factor we are getting the square meter of the cable. The second is the ampacity criteria. What is ampacity criteria? The CCC. What is CCC? Here the current carrying capacity. Depending on the current carrying capacity, we are just identifying the square meter of the cable. How? Suppose we are considering some industries, some small industries has a load of 90 kilowatt at 415 volt voltage level. So what is the current or full load current for this particular industry? For the three-phase connection, 90 into 1000 divided by root 3 415 into power factor 0.85 into 0.9. You will get 163.67 ampere. By help of this ampere, we can identify by the manufacturer's guideline, this amount of current can flow which amount of square meters. So from this list given by the manufacturers, you can easily identify by calculating the current or calculating the loads which square meters or cross sectional area of the cables is suitable for flowing of this amount of current. And the third most important is the voltage drop. So by help of the voltage drops, we can easily identify the square meter also. So what is the formula of the voltage drop is 1.732 into current into R cos phi plus J sin phi into cable length into 100 divided by line voltage into number of run into 100. So here what is 139 current? Suppose we are considering that the 80 kilowatt of power are flowing to a industrial load. So which amount of full load current is just flowing here? So by help of this formula and putting the cos phi power factor, we are getting that 139.12 ampere of current is flowing through this industrial load. So how we will calculate it? By putting 1.732 into the full load current into 0.6. What is 0.6? 0.6 is the resistance here, and 0.6 into 0.8 plus 0.1, J value is 0.1 and the sin phi value is 0.6 into 200. So what is the 200? 200 is the cable length. We are using the cable length. So for calculating the voltage drop, we have to put the length of the cable here. So we are putting here the length of the cable into 100 divided by 415 into 1 into 100. We are getting the voltage drop of 6.28%. If the voltage drop is 5% or greater than 5%, then we should have to use the 95 square mm of cable. If we are considering the 70 square mm of cable, so it will be not suitable for that. So we have to just go through the 95 square mm of cable for the suitability and for flowing this amount of current in the three-phase system. For the cable design calculations, there is lots of factors, lots of parameters. By considering these parameters, we just designing a cables. So what is these parameters? Is the K1, K2, K3, K4, K5, K6 and K7. So all are the different objects. So what is K1? K1 is the air temperature, K2 is the ground temperature, K3 is the thermal resistance, K4 is the soil corrections, K5 is the cable depth, K6 is the cable distance corrections and K7 is the cable gouting. So for the design purpose, we are using these K factors. The selection of cable, it is the most important parameters, the most important things you should have to remember the selection before selections of the cable for your domestic purpose, commercial purpose or industrial purpose. The first is the maximum operating voltage, second is fault level, third is load to be carried, root length and voltage drop, mode of installation, ambient and ground temperature, chemical and physical property of the soil. These 7 factors is most important for the selections of the right cable for right purpose. Suppose for example, for your kind understanding, we have considered a household has an connected load of 5 kilowatt. That means 5000 watt. So we have to consider the 20% above the connected load, because if sometimes there will be a heavy amount of load, then the wire connected inside the household or connected to the serviceman can be damaged. So we should have to consider the 20% more capacity for the calculation of the cable design. So 5000 into 20% equal to 1000. So P, what is P? P is the power. So we are just adding 5000 and 1000, we are getting the 6000. So this is the calculations that the 6000 watt of power should be just catering inside this household, or it may be the industries. What is the step 2? Step 1, step 2. Step 2 is in the domestic purpose the voltage level is 220 volts. So what is P? P equal to VL IL cos theta. So what is IL? IL is the full load current. If I consider that the 6000 wattage are just loading to this domestic home, so domestic purpose, so what is the full load current? We are getting the full load current of 34.09 ampere. So by help of the this is the step 3, we are getting the current, that this amount of full load current can flow through the cable for the selections of the right square meter of the cable. So from the manufacturer's guideline, we are just following the step 3. So 6 square mm cable are using for the 36 amperes of current. So here we get 34.09 ampere. We are considering 36 from the catalog of the manufacturer. So 36 ampere of current can flow through the 6 square mm of cable. So we considering the temperature of 40 degrees Celsius. At 40 degrees Celsius, correction factor is 0.87. 0.87. By multiplying the correction factor with the 36 ampere current, we are getting 31.32. It is less than 34.09. So it is not valid square meter, or the selection is wrong. So we have to select the next as per the catalog 10 square meter. So 10 square mm of cross sectional area cable can flow 46 amperes of current. So 46 ampere into correction factors, we are getting 40.02. Yes, 40.02 is greater than 34.09. So it is permitted. It is valid. So you can design or you can install the 10 square mm cable for the 34.09 ampere of current for your household purpose. So the fourth step is should not exceed 3 to 5% of the nominal voltage. So what is the voltage drop here? We should have to consider that 220 volt in a domestic purpose, the 3 to 5%. So we are considering the 3%. So 3% means 6.6 volt voltage drop. Considering we are getting 6.6 volt will be the voltage drop for the 220 volt. It is permitted. So considering the length is 50 meters from the catalog, we are getting we consider the 10 square mm of cable, because the 10 square mm cable can flow the higher amount of current, and as per our calculations, so we consider the 10 square mm. So what is the voltage drop from the catalog? 10 square mm, the voltage drop is 4.4 millivolt per ampere per meter. So we are transferring 4.4 in 10 to the power minus 3. So it is converting to the volt. Then the current 34.09. Then 50 is the length. We are getting 7.4 volt. 7.4 volt drop. The 7.4 volt drop is greater than 6.6 volt. So we can easily identify that this 7.4 volt voltage drop is greater than the 6.6 volt, and we are getting 6.6 by calculating the 220 volt 3% of 220 volt. So we are getting the 6.6. So 7.4 volt is greater than 6.6. So we are considering this right amount of cross-sectional area. So by help of these 4 steps, we can easily identify the right amount of cross-sectional, right amount of size of the cables. Okay friend, thank you for watching my video. Please share my video with your friends and colleagues. Thank you very much.